Hello again and welcome to another adventure with algebra. Today we're going to be talking about chapter 7.1 or section 7.1. We're going to look at the square root property and completing the square. Now, completing the square is a process that's going to help us do one thing and one thing only, and that's going to be our goal for today, and that's how to solve quadratics. Specifically the ones that don't factor. Now, you maybe remember from a long time ago we ran across some quadratics that don't factor, like x squared plus 4 equals 0. And that's a fairly simple one that just doesn't factor. What we're going to focus on in this section's lesson and 8.2 is ways to solve quadratics that are not factorable, so ones you can't factor. So just to remind yourself, definition, a quadratic is a degree 2 polynomial. So you could write it as f of x equals ax squared plus bx plus c. Not zoom out, I do that every time, where a, b, and c are just constants. So we're going to treat a, b, and c as real numbers for us. Yay! So for instance, some examples. The one I just gave you, f of x equals x squared plus 4. So in that one, c is 4. There's no middle term, so b is 0, and a was 1. Here's another one. So here, a is 2, b is negative 5, and c is 10. For fun, let's do one more. Still a quadratic. Here a is 3, b is 0, and c is 0. So they don't have to all look like ax plus bx plus c. It could be that some of these are 0, and therefore it just drops off, just so you know. Okay, so let me tell you about the square root property. Not 0. What was I talking about? Because this is what we're going to use. I did use this one a little bit in chapter 7 ahead of time. So if you are solving some expression u squared equals a number d, then u equals the square root of d, and u equals the negative square root of d, or u equals plus or minus the square root of d, are the solutions to u squared equals d. This is basically the idea of if I want to undo a square, I use a square root, which isn't too big of a shocker. Let's apply this property so you can see how it's used. Like I said, I did use it a little bit in the previous section without really alluding to why we need it, but we'll use it right now. So we're going to solve by the square root property. So first up, let's look at 3x squared equals 18. So the first thing I'm going to do with this is I need to get the x squared by itself, because notice I have something squared on one side. So I'm going to take the 3x squared equals 18 and divide both sides by 3. That'll take care of this 3, and I'll be just left with an x squared equals 18 divided by 3 is totally just a 6. So then, using the square root property, x has to be plus or minus the square root of 6, whatever that happens to be. And that's it. We're done. So anytime you get down to something squared equals 6, you'll apply the property and get your two solutions. Now, some of these you will have to do a little bit more than just do the plus or minus root. So notice I had to take care of the 3 first, and there's some of the ones I have coming up. We'll also have to take care of some other things. You'll see how this gets used. 5x squared minus 7 equals 0. That's a beautiful 0 I've written. Good times. Let's add 7 to both sides. So again, your goal is to get that squared stuff by itself. Let's divide by 5. So you'll get that x squared is 7/5. At this point, I can apply the property. So I've got something squared by itself. And that'll give me that x is plus or minus the square root of 7/5. Since I haven't done this yet, I'll write the two answers also. Or you could write it as x is the positive root of 7/5, or x is the negative root of 7/5. I just said sixth. That's not correct. Okay. I tend to write it this way just because it's shorter. You don't have to do that. It's more or less just habit for me. Let's take a look at another one. Now this one is very similar to the one I just did. But it's got some changes. You'll see what I mean. 16x squared plus 25 is equal to 0. Do green. I haven't done green in a while. So let's subtract 25 from both sides to get the 16x by itself. X squared equals to negative 25. Again, just trying to get that squared part by itself. Let's divide by 16. And so we've arrived at x squared equals negative 25 over 16. I'll go ahead and convert that using the square root property into plus or minus the square root of negative 25/16. Now here's where I have to be careful, because I can do the square root of 16, and I can do the square root of 25, and I can do the square root of a negative. Hopefully you remember from last class, the square root of a negative, I should always pull out an I, and then do the square root of 25 over 16. And the square root of 25 is 5, the square root of 16 is 4, so I get that x is plus or minus I 5 over 4. That's it. Kind of neat. So this is one that previously we would have looked at and said, oh, let me just undo that. I can't factor that, I'm done. But now I'm able to establish that its two solutions are I 5/4 and negative I 5/4. Kind of fun. I really should have written the 5/4 first and then the I to have proper notation, but too late now. Let's take a look at D. Now D is a little bit more complicated. And looks a lot like some of the stuff we're going to see coming up. It's not that much more complicated. So I already have my square by itself. Now there's stuff inside the square, but remember, U could have been any expression. So I've got stuff squared. So I can immediately apply the property and say that x minus 2 is equal to plus or minus the square root of 3. Now when you have something inside your square that's more complicated than just an x, I do suggest you actually write it with the or. So I'm going to write two versions. So I'll have the positive square root of 3, or x minus 2 is the negative square root of 3. And now I'm just going to add 2 to both sides. So x is 2 plus the square root of 3. Do the same to the other one. So here x is 2 minus the square root of 3. See how that works? So I've got two solutions. Both involve a root. Let's take a look at another one like this. So here I've got something more complicated inside the square, but the square is by itself. So I can go ahead and use the square root property to say x over 2 is equal to the positive square root of 7, or x over 2 is equal to the negative square root of 7. Okay, so now at this stage, hopefully you remember your algebra, and that at this, to undo, I've got x divided by 2, so I'm going to take and multiply by 2 on both sides. Should have left more room here. This looks a little weird. I'll use some parentheses. Alright, so 2 multiply and divide undo each other, so I'll get x equals 2 square roots of 7, or multiply, multiply. Here I'll get that x is negative 2 times the square root of 7. Kind of fun. Sorry about that. My phone was going off. I forgot to mute it ahead of time. Anyway, so here's your 2 solutions to that. Now this works well if the thing that you're dealing with already has a square in it, and it's what we're going to be using going forward. But what if you don't already have a square in it? That's where you're going to need completing the square. So this is one of the 2 methods we're going to learn to solve quadratics with. So I'm going to start off with, completing the square. It might not be your favorite. If it's not your favorite, that's okay. The method in the next video might be the one for you, and that's okay too. You can pick the one you like, as long as you have some method of, doing some solving of some stuff. So the idea behind this is to make a perfect square. What do I mean by that? Well, let me show you. So, for example, let's say we start off with x squared plus 8x, which seems pretty close to being something that's squared, because it's already got a square in it, but it's also got this extra x term. And what we're going to do is we're going to try to make it look like a square, a perfect square. So let me write out a perfect square for you. X plus, that's a plus sign, 4 squared is, if you FOIL this out, x squared plus 8x plus 16. So then you look at these 2 and you're like, if it just had a 16 it would be perfect, and I could write it as a something squared. So it's just 16 shy of a perfect square. And I know what you're thinking. Okay, I'll just, throw in a 16. That's all I need to do. But that changes the expression. Now, one thing that's nice, though, is if you have something that's an equation, you can add in stuff to make sure that you get something perfect. And that's what we're going to do. So first I want us to practice, though. We're here. And let me show you. A while back ago, we did some stuff. That was supposed to be an x. We had x minus a squared and x plus a squared. And we FOILed them out, and we found when I did it, I got x squared minus 2a x plus a squared, and then x squared plus 2ax plus a squared. So what you notice is that, hey, in the middle, I always get double the a. So how did I pick 4? I just took 8 and I divided it by 2. And that's how I picked 4. And it'll always work. Let's use this in our next set of examples. So what are we going to do? What term is missing? Oh, that looks like not English. To make a perfect square, trinomial. Yep. And then we're going to write and factor the trinomial. Let's see how it's done. It doesn't let me click and drag for some reason. There we go. Okay, so this first one will probably be the roughest one because this isn't that bad once you get started. X minus 10x. So looking at this, you're like, aha, using what we just saw, I gotta take this negative 10 and just divide it by 2. And that should be my value. It should be 5. Or sorry, negative 5. So that means the trinomial I should use should be x minus 5 squared. So there's my trinomial, and I've already factored it. Let's multiply it out and make sure that it works. So let's see. In case you weren't convinced, we'll write it out this way. X minus 5 times x minus 5. If I multiply this out using FOIL, I'll get x times x is x squared. X times 5, negative 5 is negative 5x. Negative 5 times x gives me negative 5x. And then negative 5 times negative 5 is positive 25. So you're like x squared minus 10x plus 25. So what is it missing? It was missing a 25. Woohoo! And the factored version of it is right there. And then multiplied out, that's what she looked like. There's the trinomial that's perfect and matches the original in A, at least the first 2 terms. Let's try this again. Let's do, come on, B, x squared plus 16x. Okay, so same game, positive 16. So what's my A value going to be? 16 over 2. It should be 8, which means I'm hoping you notice that the value that's missing is just that squared. So the missing value for this should be 64. Let's multiply the factored form out to see if that's true. So x minus 8 squared. Well, not minus 8, this is positive, sorry. Always watch for the sign on your A. A. Anyway, x plus 8 times x plus 8. So here I'll do my first. X times x is x squared. 8 times x is going to be 8x. 8 times x is 8x. Plus 8 times 8, 64. So x squared plus 16x plus 64. We were right. It's 64 and 8. Check, check. Okay, you ready for a more difficult one? I hope so. Let's do this. So x squared minus 5x. Okay. So my value here, I'm hoping you notice, is always just I take the value of b, divide it by 2, so it's going to be negative 5/2. So the missing value that needs to be added is I got to take negative 5/2 and square it, so that'll be positive 25/4. If that's not working for you, let's go ahead and do the foliage. The foliage. Ooh, that's a bad math joke in the making right there. Oh yeah. Okay. Multiply. Why am I moving so far over? I don't know. It's math time. X times x gives me an x squared. I do 5/2 times x, and it's negative 5/2 x. I'll do inners and outers. Oh, yep, I missed one. Negative 5/2 x. And then negative 5/2 times negative 5/2. Multiply negative times negative is a positive. A 5 times a 5, because you multiply the numerators, multiply the denominators. 25 over 4. Check. Let's make sure the middle matches. X squared. If I have 5/2 and I add 5 more of those halves, I have 10/2, which is 5. Don't forget it's negative. Ooh, so this one had a little bit of a grosser value that we were missing, but it does work. Let's try an even grosser one, just to make sure we're all on our toes. I must have been a little masochistic when I wrote this one, because there's some hard ones in here. What about 1/2? Okay, I'm going to take 1/2 and divide it in half and get a 4th. Yay. And then when you square it, you'll get the missing value. So my missing value, 1 squared is 1, and 4 squared is 16. So it appears that that's what's missing. Let's double check our perfect trinomial. So this should be x plus 1/4, since that's the value of a, squared. Let's do this. So I'm going to do x plus a 4th. That 4 looks weird, but too late now. And then x plus a 4th It's not too late now. It's never too late to make something look better. There we go. Let's multiply. X times x gives me an x squared. X times 1/4 gives me 1/4 x. 1/4 times x gives me 1/4 x. Plus 1/4 times 1/4. We multiply numerators to get 1. Multiply denominators to get 16. Yep, that guy worked. Let's go ahead and add. So x squared 1/4 plus 1/4 is 2/4, which is the same as 1/2 plus 16. That's not plus 16, plus 1/16. So the 1/2, I'm always checking, do these first two terms match these first two? And when they do, I know this is the right value of a. Cool. So I'm hoping that wasn't too painless, because that's how we complete the square. Now we're going to use that to do some solving. How so? Well, let me give you some steps. Completing the square. Okay, so this is going to rely heavily on what we just did. Add the missing value. To both sides. To make a perfect square trinomial. Then we're going to factor the trinomial. And solve. That's it. Now, one little tip I'm going to add to this, just to keep you, what's the word I'm trying to look for? Have an easier time at trying to do the factoring, is that before we get to even step 1, I would suggest you move the x, or sorry, I shouldn't say move. I should say make, not erase, there we go. Make one side have x and x squared terms on it. And you're going to see me do this. It just makes it easier to solve later. A little bit of a pro tip for you. Let's go through these steps, because sometimes they make more sense once I start doing them. So we're going to solve by completing the square. Are you ready? Let's do this. So I'm going to be looking at x squared minus 10x minus 12, oops, equals 0. So my first step is going to be to make the x and the x squared by itself. So the first thing I'm going to do is going to add 12 to both sides. So I just have these two alone like we had in our earlier stuff. So negative 12 plus 12 gives me 0. Those are gone. So on this side I'm going to have x squared minus 10x equals 12. And that part doesn't really matter to me. So now you need to figure out my missing value. So I'm going to do this off to the side. So I take the term on x, so negative 10 divided by 2, and that gives me negative 5. This is that value of a, and then I square it to get 25. So that's what I'm missing. So I'm going to add 25 to both sides. And that's why I left a space there, and why I'm color coding it, so you can see where this is all coming together. Sorry about that. Okay, so if I've done this right, this should be a perfect square trinomial and something you can factor. I don't care what the other side's doing until later. So I just made x squared minus 10x plus 25 equals 37. That's a fun number. Don't even care. Here we go. So I've got this on this side. We're going to double bubble this so we can prove to ourselves it is a perfect square. Don't drop the 37, though. It does kind of matter. I need things that multiply to make 25 and add to make negative 10. Hopefully you see an x minus 5 and an x minus 5 in that. So I really have x minus 5 squared. Nope, come on. Equals 37. Now we're at the fun part. Now we're going to use that square root property we were using, the square root property we were using earlier. I've got something squared equals something else. We're going to use the property. So then x squared minus 5 is either the positive square root of 37, or x minus 5 is the negative square root of 37. And then we add 5 to get x by itself. Remember, since 5 is not under a root, you can't combine those. So here I get x is 5 plus the square root of 37, and x is 5 minus the square root of 37 are my two solutions. And that's it. That's how you do this. It's kind of wild, right? So first thing up, we're going to do some of the stuff we were just doing where we find the missing value, and then we factor, and then we solve using the square root property. That's the whole purpose of completing the square. So we can solve. Let's do another one. Okay, first up, what do? I want to get rid of that 3. Oops, I accidentally moved that, sorry. I want to get rid of that 3. So I'm going to subtract 3 from both sides. So I get x squared minus 5x equals negative 3. That was really loud, I'm sorry. Cool, now I need my missing value. Hopefully this looks familiar. Alright, for missing value, I gotta take negative 5, divide it by 2, and then I square negative 5 halves, because that's the thing I gotta add. That'll give me 25 over 4. So I'm going to add 25 over 4 to both sides. Got to be comfortable with your fractions. Perfect. Okay, now this is the perfect square trinomial. X minus 5 over 2 squared. Remember, this value is a equals, okay, now I have to be careful because I really need to combine these fractions together. So I have negative 3, I'm going to leave some space, plus 25 over 4. I'm going to need to change this into fourths. So I'm going to multiply by 4 over 4. I'm just going to go over. So 3 times 4 and 1 times 4 gives you negative 12 fourths plus 25 fourths over 4. So 25 minus 12 will give me a 13. That's kind of gross. Oh well. Sometimes ye shall not get pretty number. 13 over 4. All right. Now that we have a single value on that side, we can go ahead and use our property. Woohoo! So we get that x minus 5 halves is equal to the square root of 13 fourths, or x minus 5 halves is equal to the negative square root of 13 fourths. Perfect. And we're just going to add our 5 halves. Remember, it's not under a root, so you can't combine it. So don't try to add these two, is what I'm saying. Don't try to add the square root of 13 fourths to 5 halves. You 100% can't do it. All right. So then we get that x is 5 halves plus the square root of 13 fourths, which I could reduce this, but I'm not going to. Yeah, I probably should. X is 5 halves minus the square root of 13 fourths. So you can do one other change to this, and that's to say that, okay, well, I know I can't do the square root of 13, but I can do the square root of 4, which is 2. So you could do that and then say, hey, I know they have the same denominator. This is 5 plus the square root of 13 over 2. And then similarly, this one will be 5 minus the square root of 13 over 2, which your book might write it any of these ways. So prepare yourself that, like, they might not look exactly the same, but if you move things around a little bit, you'll algebraically get the same thing. Cool. Let's do another one. I don't know if you're going to like this one, but I believe in you. Let's do 2x squared minus 6x plus 5 is 0. Now this one's going to be a little wilder. I know, you thought the last one was kind of wild. I believe in you though. Whew. So the first thing I'm going to do is I'm hoping you notice I haven't done a single one of these where the x had a value in the front of it. So the first thing I'm going to do is to make sure I get rid of that. So I'm going to divide everything by 2, because you can. So then I'll have x squared minus 3x plus 5 over 2 equals 0. And we have the same problem earlier. I want to have the x squared and the x term by themselves, so I'm going to subtract 5 over 2 so that I have them by themselves. Then I'm going to find myself that missing value plus something equals negative 5 over 2. Perfect. Missing value time. What's my a? Let's find the missing. So a is going to be negative 3 over 2, which means the missing value that I'm going to have to add is going to be negative 3 over 2 squared. When we square that, we get 9/4. So I'm going to be adding 9/4 to both sides. That doesn't look like a 4. And there we go. Now we have a perfect square on one side. Now on the other side, I got some fractions. So on this side, we're going to combine that into a perfect square trinomial, x minus the value of a, which is 3 over 2, squared. Let's make it a little clearer. That's a minus sign because that looks a little bad. Equals fraction time. So I got negative 5 halves. I'm going to have to multiply that to make sure it has a 4 in the denominator. Plus 9/4. So I need myself a common denominator. 2 times 5 will give me 10/4 plus 9/4. Oh, that comes out kind of nice. 1/4? Pretty! Oh, negative 1/4. Let's be careful. So I have x minus 3 over 2 squared is negative 1/4. Let's use our property. So we're going to use the zero factor property at this stage. Prop it up. So I've got x minus 3 over 2 equals the positive square root of negative 1/4, or x minus 3 over 2 is the negative square root of 1/4. So I'm going to clean this up because that, or negative 1/4, sorry. Boy, is that not pretty. Okay, so negative roots, we know how to deal with this. We have complex numbers, that's going to be I. The square root of 1 is 1, the square root of 4 is 2, so I'm going to rewrite this as I over 2, and that's still equal to x minus 3 over 2. Or x minus 3 over 2 is negative I over 2, because it does the same thing. Negative pulls out an I, square root of 1/4 is 1/2. Good times. Now we're just going to add our 3 halves. Man, this one took up way more space than I anticipated. Bloop, bloop, bing. What's my x? It's 3 over 2 plus I over 2. Did you see that one coming? And x is 3 over 2 minus I over 2. So it is possible for you to get complex answers off of this. Previously, you would have looked at all of these and just said, oh, I can't factor, I'm done. And that would have been the end of them. But now you have 2 tools that help you actually be able to solve any quadratic you come across. But your answer might be complex, which is why we bother with complex analysis. It allows us to solve any quadratic, which is really powerful and hopefully helpful. That's all for me, and I will see you in the next one.